Hello, everybody. I'm Benoit from Apollo. Today I'm going to talk about the caching features of Apollo Kotlin and Apollo iOS and what's new and what's coming up. Just a quick reminder of what these two libraries are. So these are two GraphQL client libraries that generate Kotlin and Swift code from your operations. So the code is strongly typed, so that makes your code, sorry.
Come a little bit closer to the microphone.
Oh, yeah. Sorry. So yeah, generated code is strongly typed. That makes your code robust and nice to use from an IDE. You can call the generated operations directly from your code, and you don't have to implement JSON parsing or anything like that. It's GraphQL spec compliant. By that, I mean we try to closely follow the spec. We also try to implement new developments as they come. So I'm thinking, for instance, of one-of or defer. The libraries have been around for a few years. So Apollo Kotlin is in version 4 with V5 alphas available. And Apollo iOS is V1 with V2 alphas available. And both libraries come with an implementation of a normalized cache, which is what I'm going to focus on today. Quick reminder again about what a normalized cache is. Well, this example summarizes the main idea of normalization, which is taking key value structure that can be arbitrarily deep and flattening it into a bunch of records that have only one level. So here, for instance, on the right, we have three level deep, repository, pull request, and author. And we flatten this into three records that have only one level. So why do we do this? First of all, if your operations return the same entities that will be stored with the same key, so that can avoid some network round trips. And also your UI can observe these records to update itself whenever they change, no matter which operation was the cause of this change. One thing to notice is that it's important to have IDs on your entities for normalization to work well, and for a normalized cache to be efficient. Okay, with that out of the way, I'm gonna let's look at what's new and upcoming with the cache. I'll focus a bit on Apollo Kotlin because that's what I work on, and we have a new library that we were very original, and we named it Apollo Kotlin Normalized Cache. But basically, the code for the cache used to be with the rest of the library on the main repo. But now we have this new home where we work on the next iteration of the cache. Let me open the repository. As you can see, this is still alpha, so maybe not 100% production ready yet. But we do encourage you to have a look, try it, experiment with it, and open feature requests or any issue you may have, because we really want this new version to fit all your use cases. So the documentation is here, and today I'm just going to demonstrate two new features, starting with pagination support. So again, documentation is here, but let me switch to my IDE. And yeah, so I have just a little demo app here which lists repositories from the GitHub API. So how would you implement something like this in Kotlin and with Apollo Kotlin on Android? Well, first of all, start by executing a query. So that's what we do here. Let's have a look at this query. So we select an organization, and for that organizations, the repositories. If we look at the schema, we can see that indeed that returns, sorry, it should be here at the end, that indeed is a paginated API that returns a connection. If you saw Michael's talk on Monday about pagination, you know that this is one of the best way to do pagination. It's cursor-based pagination. Let me go back to the code here. Second thing you want to do is observe your cache. So whenever a new page comes, your UI can reflect that. So that's what we do here with watch. And you also need a mechanism to fetch new pages when the user scrolls. So that's what we do here. Here we have, there's several ways to do this, but here we just show an item at the end of the list that will fetch a new page when it's visible. But the problem is, when you fetch a new page, this page will land in its own record, independent of the other records that may be already there for the other pages. And moreover, here you're watching only the first page, because this is the query to get the first one. So you scroll down, you add new pages, and your UI only doesn't reflect that. So how do you fix this? Well, you can merge several pages in the same record, in one unique record, to fix that issue. And previously, you could do that manually with the low-level cache APIs. But now the library does this for you. How to do it? You extend your schema, and you basically tell the library that you have a field that is a connection field. So here I'm saying repositories on organization is a connection field, and from that, the different pages will be merged together in one unique record that your UI can observe. So if we look at how we fetch a new page, we look at what's currently in the cache to get the next cursor for the next pages. So that's what we do here. And then we do the same query again with the new cursor for the next page. And that's it. The library will merge it on one record. That's what the UI observes. So if I scroll down here, yeah, I'm getting the next page, and it has been merged with the existing page. The UI reflects that. All right, so that worked. So that was pagination. The next thing I want to show is expiration, also known as time to live. So this is also something that has been highly requested. We didn't have much before this new version. You could have your own mechanism where you basically clean the database from time to time, or have your own database of like dates mapped to your entities. But now we have something built in. I will show it quickly. So for the demo here, I'm just going to say that the organization type expires after a few seconds. So again, you do this by extending the schema. So I'm going to extend the organization type and add the cache control directive, which I have to import. And I'm going to say max age 10 seconds. And that's basically it. By doing that, the library will consider the fields of this type to be expired after 10 seconds. So how does it work internally? Well, basically within each field that we store in the cache, in addition to its value, we now store the date it was received. And then later, when you resolve that, we compare this to the current date. That gives you the age of a field. Then we can see if this field is above this max age. If it is, we consider the field as stale. So that's basically a cache miss. Let's see if it works. So I'm gonna reinstall the app quickly. And this time I'm gonna show, oops. I'm gonna show the network requests. Okay, so that was the first time you had a network request, of course, because the cache was empty. I'm gonna restart it quickly. And I was not quick enough. Sorry. I'm gonna start it quickly again. And yeah, I was under 10 seconds this time, so no new network call. And now wait a few more seconds and restart it once again for the demo. And yeah, this time I was a bit slower, so the organization was stale, and so we couldn't use the data from the cache. We went to the network. Okay, almost finished. Just a few more new upcoming features. Expiration, I just talked about it on Android, but it's also coming on iOS. It will be fairly identical because we're going to reuse the same at cache control directive. In the same vein, if you want to keep your cache size under control, we have a few features for that. So garbage collection, removing just making sure that what's not used is no longer in the cache. Trimming is about removing the old records from your cache. And similar features on iOS are also coming about how you make sure your cache isn't taking too much space. Partial results on Android. Before, if you had at least one field that was not in your cache, the whole response would be empty. So now you get whatever is in the cache. More fine-tuned API for observing your cache on iOS are coming. And we also have enabled the JavaScript and WASM targets for Android. So if you're into Kotlin multi-platform, you can enable that and have a working cache in the browser. Last but not least, performance. So we've optimized the cache. So you should see some speed improvements there. And that's pretty much it for me. My main takeaway: please try the libraries, and we'll be happy to receive feedback for that. And yeah, that's pretty much it for me. So. Yes. Yes. Yeah, I guess it depends. That's always an answer. So we thought also of having these max edges on the backend and retrieving them on the client. As far as the client is concerned, I guess this is an application choice, so you would define them once for the whole application. Yeah. Yeah, yeah. Yes. So yes, defining the I didn't mention that, but first of all, you can define the max age per field, and also we're thinking of having a way to define them on the operations directly. So yeah, that's not available yet, but yeah, coming. Yeah. Yes, yes, the shortest one. Yeah. I'm sorry. Can you repeat that? Not sure, but again, with partial results, you can get whatever you have, which is not stale. And also, we have like a max stale option, so you could get the data even if it's expired, actually. All right. Thank you.